Okay, another true response question. This one is calculator active. So you can imagine that probably some of the calculations are going to be a little tricky, which if we glance at the function that they give us, we can see that it is. It's trig mixed with an exponential function. And judging based on what we typically have to do with particle motion, you got to take derivatives, you got to take integrals. So the calculator is going to come in handy here. Okay, between time 0 and 6, remember always take note of your time. Particles move along the x-axis just like the previous problem. The particle's position, x of t, is not explicitly given. They don't give us the position. They do give us the velocity. And then the acceleration, they go ahead and give us that derivative. So it's not really that difficult of a derivative to figure out, but they go ahead and give it to us. And then they also, once again, give us an initial position. At time 0, the initial position is 2. So right out of the gate, they ask us a question: is the speed of the particle increasing or decreasing at time t equals 5.5? So remember, we just talked about this. Speed increasing or decreasing, we're comparing the sign of velocity and acceleration, which, I mean, is really easy right here because it's calculator active. So it's just a matter of being able to plug it into your calculator correctly. So let's do that really quickly. I'm not even going to write it down. I'm just going to write down v at 5.5, and I'm going to go straight to my calculator and start working this out. So 2 sine of e to the 5.5 over 4. Close my parentheses on the exponent, close my parentheses on the trig function, and plus 1. Make sure that I am in radian mode, always in radian mode for calculus. Okay, press enter so we get negative. Okay, so a of 5.5. Let's see what we get there. 0.5 e to 5.5 over 4. Cosine of e 5.5 over 4. That's all. Okay, so it is negative. So just like the previous problem, velocity and acceleration have the same signs. Since velocity and acceleration have the same signs, t specific at t equals 5.5, because it's not always, but at this particular time they do, then the speed of the particle is increasing at this time, or at that time. Okay, so that's part A, conclusion with a reason, just like in the first problem we did. B, find the average velocity of the particle. Okay, average velocity, we should be thinking average value, which should be making us think 1 over b minus a times the integral from a to b of that function itself. So we've got 1 over, it's from 0 to 6, so 6 minus 0 times the integral from 0 to 6 of v of t. This is calculator active, so again, save yourself some time and effort and just write it like that, and then just plug it straight into your calculator. Okay? 1 over 6 integral velocity 2 sine e. Remember, we're going to use x on your fancy calculator. You can use a different one if you want to, but parentheses, comma, x, comma, 0, comma, 6. So they give us the value there, 1.949. And it didn't say include units. Well, we can't include units because they don't say that it's feet per second or meters per minute or anything like that. So we just got to use it like that. You get 1 point for setting up the integral, you get 1 point for the answer. Don't try and do it by hand. You can't do it by hand. You cannot do that by hand. We do not have the techniques necessary to evaluate that interval by hand. Use your calculator when it gives you permission to use your calculator. Okay, take advantage of that. All right, part C, find the total distance traveled by the particle. Okay, again, total distance traveled. Think about your path along the day. You end up back where you started in the parking lot, okay? So your displacement is 0, but your total distance traveled, you got to take those negative distances and make them positive. So the total distance traveled here is going to be the integral from 0 to 6 of the absolute value of the velocity function. So again, you get 1 point just for setting up the integral. I'm going to try and use this. So I've already got it mostly, because that's the velocity function that I have in there right there. I just need to put the absolute value. Okay, oops. Oh, my 2 disappeared. All right, absolute value of 2 sine of blah, 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 blah. Close my parentheses here with my absolute value. Okay, and we get, it'll take a minute. And we'll take that many minutes, but there we go. 12.573. You get 1 point for setting up the interval, you get 1 point for the answer. Okay, let's look at D. 4 times 0 to 6. The particle changes changes direction exactly once. Find the position of the particle at that time. So first of all, we're going to find where the particle changes direction. So remember, particle changes direction, that's velocity equals 0, so set v of t equal to 0. You get 1 point just for considering that. Okay. Now, to be honest, the easiest way to do this would be to graph it. Okay, that would be the easiest way to figure that out. So let's graph it. The velocity function 2 sine of e to the x over 4 plus 1. Okay, and now before I graph this, I'm going to change my window because I'm only concerned between time 0 and time 6. So I'm going to go ahead and change my x min to 0, my x max to 6. And I mean, I can leave the y values. I could technically zoom in if I wanted to because I'm just concerned about where it changes, where it crosses the x-axis. Okay, so second calc 0. You know what? Let me show you a shortcut to this. Did you know that when you do this, you can type in values, okay? I know that obviously it happens between 1, 2, 3, 4. It looks like it's after 5, but let's use like 4.5 as our left bound. And our right bound, let's go with 5.5. Okay, see, it definitely happens between my 2 arrows here. Okay, and then I can press enter. I could have moved my cursor if I wanted to. Okay, so I get t equals 5.1955223. Now, do not round in the middle of the problem. Never round in the middle of the problem. Write down all those decimals that you can. Okay, so we get that answer. So we need to set up our interval now. Okay, we are finding the position when it changes direction. So it changes direction at this time. Now, one thing that they tend to do on the exam is when they find something like that, they'll let it equal some random variable like c. So then they would just write s of c is equal to, don't forget, where's our starting point? 2 plus the integral from 0 to, instead of having to write out that big long decimal, they'll just use that variable there of our velocity. Remember, the integral velocity gives us total distance, or gives us displacement. Okay, we don't want total distance this time. We want in relation to where we started. And then we can type that in. 2 plus, not right there. 2 plus the integral of our velocity function. You think I have this memorized on that. 2 sine e to the x over 4 plus 1, comma, x, comma, 0, comma, 5.1955223. Now, I know that you have a copy feature on the 89. I don't know if you can copy a 0 from your graph, but if you can, that'd be great, because that would be great accuracy. And then you want to type that in, and you get 14.134 or 435, whichever way you round or truncate. So you get 1 point for considering the velocity equals 0, finding that value. You get 1 point for setting up your integral, and you get 1 point for your answer.